Professor Bialis here. In this video we are going to be covering section 2.2 and 2.3. 2.2 talks about the basics of equation solving, and then we expand on that in 2.3. I prefer to just talk about the whole idea of equation solving in one fell swoop. Now, this discussion that we're going to have in this video is going to be extremely important for anything you do after this in mathematics. If you can't solve an equation, you really can't do anything else. There's not much for me to tell you about this, but there's a lot of repetition and practice that need to be put into place. So what I like to start with is as hard of an example as we are going to see. We're going to go through it step by step, see how the steps are going to play out, and then we're going to backtrack a little bit, go through some easier ones, and just drill through some more examples. So let's get started. So again, this is section 2.2 and 2.3. We are solving equations. Okay, so first thing we're going to do is jump right into something like this. Okay, now again, there might be some problems that you personally look at later on that have some trickier aspects to it, but this is as long of a problem as we're going to see in this section. Okay, so when we look at an equation like this, remember that golden rule that I'm sure you've heard in the past. What you do to one side, you do to the other. Okay, that's the addition property of equality, multiplication property of equality, and all that good stuff. Now, why we're doing that is right now we have a balanced equation. Whatever's happening on the left is also happening on the right, and it's balanced. If I take something away from here, then this is going to be off balance. So if I take away 3 from here, I have to take away 3 from here. If I divide by 5 here, I have to divide by 5 here, and so forth. So keep that in mind as we're going through. Now, these are still, though, two expressions. You got an expression on the left, expression on the right. The first thing that we want to do is lay everything out. So these are steps for solving equations. Step 1, if you can, distribute. Okay, that lays everything out for us. So I'm going to do that here. 3x plus 20x plus 28 equals 3 over 2x minus 5 over 2. Don't let this fraction trip you up. All you're doing, when you have a fraction and an integer, you multiply the numerator with the integer. 1 times 3 is 3, and I carry down the denominator. 1 times negative 5 is negative 5, and I carry down the denominator. Nothing more to it than that. Okay, so I laid it all out. Now the next thing, and this is something that we can do with equations, because remember, what you do to one side, you can do to the other. I don't like fractions, so I'm going to clear them out. So the second thing I'm going to do, if possible, is clear fractions. Okay, now how do I do that? What I'm going to do is I'm going to multiply both sides by the LCD of the equation, of all the fractions that we see in the equation. Now, when I multiply this side and this side, both by that common denominator of 2, what would I do with that? I would distribute it eventually, wouldn't I? So instead of showing that distribution, what I personally like to do is just jump right into multiplying every term by the LCD. Okay? So if you want to, give yourself a little added note here. Clear fractions by multiplying every term by the LCD. Okay? Again, why we're doing every term is because we multiply the whole side and then we distribute it. Now watch what happens. These are all going to just plain old multiply. So I've got 6x plus 40x plus 56 equals, now what happens here? The 2's cancel. And now I have a nice clean 3x. If you don't feel comfortable doing that, then what you can do is take 2 times 3 divided by 2, and then if you're using a calculator, you can hit enter, and it'll give you that 3. Same thing here. 2's are gone. I've got that minus 5. Now, remember, to solve an equation, to check your answer, we can take the answer we get and plug it back into the original and make sure both sides are equivalent. I personally think it's too late at that point. Okay, that's a good way to check it. I'm not saying that's a bad thing to do, but we should be checking as we go. You do a step, double check it before you move on. Okay? Now, after this, we laid it all out with distribution. We cleaned it up with clearing the fractions. The next thing I would do is shorten it if possible. And we do that by combine like terms. And I'm going to add a little bit to this. Combine like terms on the same side of that equal sign. Now what I mean by that is I'm not concerned about combining this, this, and this. I just want to combine terms on the left, combine terms on the right. Okay? So simply add 6 plus 40 is 46x plus 56, and then 3x minus 5. The rule of what you do to one side, you do to the other doesn't really apply here because this isn't something that we created. We created these 2's. So we have to put that on both sides. But here, we're just doing what the problem tells us to do. Okay, so we combine like terms. The next thing that we want to do, to have an equation solved, we want to have x equals 7 or y equals 13, something like that. So we need to get the variable on one side. So that would be step 4. Now notice I didn't say get it on the left or get it on the right. Get it on one of the sides. I personally like to put it on the side that will leave it positive. If I subtract this 46x over, I would have a negative 43. That's not wrong, but I have a negative now I got to deal with. So instead, I'm going to subtract 3x, and I'm going to get 43x plus 56 equals negative 5. Then, what I would do for step 5, you could say use the addition property of equality. I like to keep it simple. I just say undo addition and subtraction. Now what do I mean by that? I mean go to the side that the variable's on, and I've got 43 times x plus 56. Undo that plus 56. So I'm going to subtract that 56 away, but if I do it on the left, I do it on the right. 56 minus 56 is gone, it's nothing. So I have 43x negative 61. Okay? And then the last thing, I need to get the variable by itself, so I'm going to take this 43 times x and I'm going to undo that. So the last step is undo multiplication and division. Okay? Or division. So what do we have is divide that 43. And we got that. A lot of people want to pick up their calculator and then automatically get some decimal. Decimals are not the greatest thing because if they don't come out nicely, people always want to round them. And then your answer's wrong because it's not the exact answer that we're looking for. Always reduce this. You don't want to leave like a 2 over 4. But if you get a fraction, just leave it. There's nothing wrong with it. I would just suggest keeping it as is. And here's your answer. Okay? So again, what you do to one side, you do to the other. And this whole time, what we were trying to do is get that x by itself. Because when we have the x by itself here, we have a number on the other side for our solution. These 6 steps that we covered here are not going, there's not going to be any more than that. There could be less. Sometimes all we have to do is step 6, or all we have to do is step 5. Okay? But this is everything that could possibly be thrown at you in an equation. So let's look at a few more examples of this. let's do something simple. I just want you to solve, and we've got, okay, if you feel like you know how to do this, pause the video for a second, try this out, and then hit play, and I'll be here waiting for you, and I can go through the explanation. Okay, so when we're going through something like this, start on the top. Distribute. There's no distribution to be done. Clear fractions. There are no fractions. Combining like terms. These aren't like terms, and this is by itself. Next, get the variable on one side. It already is. So guys, right away, 4 steps, we didn't have to do them. Okay? Next, I want to undo plus 5 by subtracting 5. I got 2x coming down. 13 minus 5 is 8. And then I undo 2 times x by dividing by a 2. And now here, 8 divided by 2 comes out nicely, and you get a 4. If you want to check, you would take that 4 and plug it in. 2 times 4 is 8. 8 plus 5 balances out to that 13. Okay? However, I would suggest do this minus 5, check it. Do this divide by 2, check it. I would rather you, and you would rather as well, catch your mistake right away than do 5 or 6 steps and then realize you messed up in step 1. Okay? Let's do a couple more. How about that? Okay, so first thing, distribute. There is some distribution to be done. Don't do anything else with the problem, one step at a time. I've got 8x minus 12 plus 7 equals 3x plus 5. And like I said, I'm going to check. 8x, negative 12, 7 coming down, 3x, 5. We're good to go. Okay. Next, what we're going to do is clear fractions, but there are none. Combine like terms on one side of the equal sign at a time. So these are like terms. So I can take 8x, negative 12 plus 7 is negative 5. And then that right side just drops right down. Next, get the variable on one side. Right now we have a variable on both sides. We don't want that. So I'm going to take this 3x and bring it over here. If you want to bring the 8, that's fine, but then you're going to end up with a negative. So I'm going to subtract 3x to get 5x minus 5, and I bring down that positive 5. Next, I would undo this minus 5 by adding it. Those are opposites, so they cancel out to nothing. And I simply have a 5x and then a 10. Next, I'm going to divide by 5. And x equals 2. Now, if you'll notice that first problem that we did, the answer was not so nice. I don't want you to look at those ugly answers and say, oh, I must have gotten it wrong. Okay? However, I would maybe double check those or go through them again, because if you do something wrong, you're more likely to get an ugly answer than a nice answer like this. Okay, so I want you to be open to any type of result that may come out of these equations. Sometimes they're nice, sometimes they're ugly. Okay, just take your time, do a step, check it, do a step, check it, and then you'll start catching those mistakes before they end up in the answer. Okay? How about this? Okay, so again, first thing, I'm going to distribute. So I take that 8, I get 16 minus 8t equals negative 5t. After that, there's no fractions to clear. There's no like terms that I can combine. So next I'm going to get the variable on one side. Now, the previous examples, I've always gotten this over here. But here, I want to take this over to the right because that'll end up positive. So I'm going to add an 8t to get 16 equals 3t. Okay, again, the variable just has to be alone on one of the sides. Either one will work. And then to finish this off, there's no adding or subtracting going on, but I can divide that 3 to get 16 over 3. And I would leave it like this. Okay, a lot of people again are going to say, let's say, what, 5 and 1/3. That wouldn't be wrong. However, when we deal with algebra, when there's nothing in between, it's understood to be multiplication. And when we use mixed numbers, we're bringing back that addition idea. Try to stay away from mixed numbers. Okay. Again, it's not wrong. It's just not typically used in the algebraic setting. The other thing is, I see a lot of people do this. That's wrong. Okay, because that 1/3 should be 3 repeating. This is okay, but it's a little bit more cumbersome to work with if you need to use that number somewhere else. This is definitely not okay because you just rounded it and changed the actual answer. So again, I would just stop here, save yourself those extra steps of translating it into a decimal, and then keep your answer as is. Oops. How about this? Okay, so what we're going to do here, nothing to distribute, clearing fractions. Now remember, we clear fractions by multiplying every term by the LCD. First of all, how many terms are there? There's 1, 2, 3, 4 terms. And now the LCD is going to be the common denominator between a 2 and a 3. Okay? Between 2 and 3, we're looking for a multiple, common multiple, of 6. So I'm going to multiply every term by 6. I see some people wanting to multiply this by a 2 and this by a 3, but then we're not doing the same thing to both sides anymore. So we have to pick a number that will be enough to work for both or all of the denominators in the problem. Okay, now watch what happens. 6 divided by 2 is 3. 3 times x is 3x. Again, 6 divided by 2 is 3, and then 3 times x. 6 times 1 is just a 6. 6 divided by 3 is a 2. 2 times 2 is 4x. And then 6 times 3 is 18. Okay? Again, what you could also do is 6 times 1 divided by 2, that'll give you a 3. 6 times 2 is 12. 12 divided by 3 will also give you that 4. Okay? Whatever way works for you, stick with it and just repeat, repeat, repeat. Okay, after that, we can't combine any like terms. Okay, so then we're going to get the variable on one side. I'm going to bring this over to the right. Now, I sometimes you're going to think, well, I'm used to the variable on the left. Then put it on the left. Okay, if that negative is not an issue for you, but putting on the right is, then avoid it. And then, again, do what's comfortable for you. So these are gone. And then I'm going to add 18. Negative 6 plus 18 is 12. Okay? How about this? Now, this one is a little bit more complicated because this fraction is not just like a 1/3, okay? But we're going to still go through the same steps that we did before. So, first thing, distribute. I'm going to take that 2 and distribute it over that binomial. So I have a 2a plus 6 all over 3 equals 6a plus 2. Next, I'm going to clear fractions. Now, the two questions you should always ask yourself is, how many terms are there, and then what's the LCD? First of all, how many terms are here? In this case, there's only 3. there's one quotient, one product, and one constant. Okay? 3 terms. The LCD is the only denominator, which is 3. Okay? Now, the next thing to do is to reduce that fraction out. These 3's are gone. They wiped each other out. This just carries down. There's nothing left to distribute. Then we've got 18a plus 6. Next, we are going to get the variable on one side. I'm going to subtract 2a. Get 6 equals 16a plus 6. I can subtract a 6. Undo that addition. And then divide by 16. And 0 divided by anything, that's just a 0, and we're good to go. As I've said in previous videos, try to do this with try to use the calculator as little as possible when you're going through this. Okay? Now, something like a 0, you should be able to plug that in and do that calculation in your head. Okay? But if it's a number like a 2/3 or something as an answer, maybe pick up your calculator on that if you're going to check it. But this is a good spot to practice your arithmetic. If I plug in a 0, 0 plus 3 is 3. 3 times 2 is 6. 6 divided by 3 is 2. 6 times 0 is 0. 0 plus 2 is 2. 2 equals 2. Our answer's good. Okay, so check as you go. Check at the end. Always be practicing all these different processes. And then as you do more and more of them, it's going to be a breeze. Okay, let's do a couple more. These are special circumstances, so really pay attention to these. Let's see how they play out. Okay, first thing, distribute. So I've got 4x plus 16 minus x equals 2x plus 22 plus x. Next, I'm going to combine like terms to shorten this thing up. So I've got 4 minus 1 is 3x. 2 plus 1 is 3x. And we're here. Now, the next thing to do is get the variable on one side. Watch what happens. I don't care which side you're aiming for. I'm going to be subtracting 3x. And when I do that, the variable's gone. I see a lot of people do this and say, just put an x because there has to be an x. If the x goes away, it goes away. And what we're left with is 16 equals 22. So no matter what you plug in for x, it's going to come down to a 16 and a 22. That's not true. So when you have a statement with no variables left, and it's an untrue statement, you say no solution. No matter what you plug in, 16 will never be equal to 22. You're done. Sometimes what we do is that empty set symbol. For me, I don't care either one, but if you have someone else as a professor, please, or as an instructor, please ask them which they prefer. Okay, let's do one more. Let's try that. Same process. We're going to distribute. Again, before I move on, just double check that, make sure I wrote everything down correctly. Then I'm going to combine like terms because there's no fractions. Now, what do you notice? You do the same on both sides. I would take one extra step and get that variable on one side, but just like the last one, when we do that, they're just gone. And we're left with this. Now, what's the difference between this and this? This was not true. No solution. Here, it is true. No matter what we plug in, this is going to balance. This equation will work. So what we have is all real numbers. I have a lot of students who want to say infinitely many solutions. While that's true, that tells us how many there are. It doesn't describe what they are. This is the better way of giving that result. Okay. Same thing here. I see some students want to say undefined. A number can be undefined. Some expressions can be, it can be undefined, but an equation has no solution. Okay, so make sure we're using the appropriate comment or the appropriate statement when we're describing these things. Okay, so that's it for equation solving. Again, really what it comes down to is this. Know these 6 steps. Put them on a note card, have them in front of you as you're going through these problems. And just keep practicing. That's really all it comes down to. Now, there are a couple other things that they introduce in this section that introduces the idea of problem solving and word problems, which we will spend most of our time on for the rest of this chapter. So I just want to talk about those 2 quick things, and then that'll be it for this section. Okay, so one problem would be something like this. A 9-foot board is cut into 2 pieces. If one piece is X, express the length of the other. Let me go over here. Piece. Okay? All we're doing is setting up an expression. We're not solving anything right now. So we have a board. There's my board. It's 9 feet long. I'm cutting it in 2 pieces. Now when I cut it, don't cut it in the middle, because they didn't say you cut it in half. They just cut it in 2 pieces. Make sure it is visually very clear that the pieces are different length. Okay? If the algebra works out that they're the same, it'll work out. But you don't want to look at it and say, oh, just divide by 2. That's not necessarily happening. So make it very clear that they're 2 different lengths. One piece is X. Express the length of the other piece. Okay? Now, this piece right here, I think we would all agree, is that leftover chunk of the board. Whenever you have leftover, whenever it's leftover, all we are going to do is take the total minus the part or parts we know. Okay, what I mean by that is, if let's say this was 2 feet, what's left here? 9 minus the 2 would be left with 7. If there were 3 here, 9 minus the 3 would give us the 6. But if there's X here, total 9 minus that X that we know. And that is how we would set that up algebraically. Again, I want you to generalize this by thinking it's a leftover problem. There's something left over. You take the total minus the part we know. That will work every single time. Okay? That's one general setup that they throw at you. The other one is a little bit more in depth. So let me clear this board. And this next one, you are going to see time and time again. It is not going to go away. The setup that I'm going to talk about here is going to be the same setup here, or if you see it in a finite math class or anything like that. So the type of problem we're going to discuss right now is consecutive integers. Okay, now consecutive integers could also be presented as consecutive even integers and consecutive, I'm going to abbreviate here, odd integers. Okay, now first of all, when we talk about integers, just remind ourselves Integers are the set of all those solid numbers. Like so, but it's positives, negatives, and 0. Okay? Consecutive simply means one after the other after the other. 3 and 13 are not consecutive. 3, 4, 5, 6, those are consecutive numbers. Okay, now, regardless of which one we are talking about in a problem, they're always going to describe how many first. Are there 3 of them? Are there 15 of them? Okay, so the first thing we do is always list how many there are. Okay? If there's 2, then you list first and second. If there's 5, first, second, third, fourth, fifth. Okay, but list how many there are. We have to start somewhere. These are all going to be integers. So this is some number. It could be 5, it could be 15,000. We don't know, but it's some number. Now, if we want to get to the next number, let's say hypothetically this was 17. What would be the next consecutive integer? 17, 18, 19, 20, 21. What are we doing every time? We're adding 1 to the previous number. 17 plus 1 is 18, plus 1 is 19, plus 1 is 20, and so on. So that's what we're going to do here. Whatever number we started with, we're going to add 1 to it. Then we're going to take this guy, and we're going to add 1 to that, and it's going to be x plus 2, because 1 plus 1 gives you the 2. Then we're going to take this, add 1 to that. And we can continue that pattern as many times as we need. This is how we set up consecutive integers. Now if it's consecutive even integers, now we're talking 2, 4, 6, 8. Okay? So I'm still going to list how many I have. Okay? First one is always x. I got to start somewhere. Okay? Now let's go back to that 2, 4, 6, 8. Those are consecutive even numbers. What do I do to a 2 to make it a 4? I don't add 1, I add 2. Then 4 plus 2 gives me 6. Plus 2 gives me 8. Plus 2 gives me 10. That's what we're doing every time. Okay, and again, the 2 is being added to the previous, x plus 2. X plus 2 plus 2 more gives you a 4. X plus 4 plus 2 gives us 6. Okay, and that's how we build it from there. Consecutive odd starts out the same way. Except the rest of it's a little counterintuitive. You think odd, you think, okay, I'm going to add 1, then 3, and so on. But if I start with like a 13, that's an odd number. If I then add 1 to that, I get 14, that's an even. So that doesn't keep me odd. I know that this is some unknown odd number. Stay odd, I have to add 2 again. Again, the even numbers there kind of throw people off because we're thinking odd. But to start odd and then stay odd, we have to be adding those evens as we go along. Okay? So this is how we would set these up. These aren't 3 unique setups. There's 1 and then 2 different and then 2 setups. So 1, 2, that's it. Okay? Now, the type of problem they're going to show you in this section, let me just make some room here, would be given 2 consecutive even integers, or let's say given 3 consecutive even integers, express the sum of the first and third. Okay? Now, we have how many integers? We have 3. First, second, third. No matter what kind of integers they are, I start with x. But then, to get the rest of them, it's consecutive even integers. So what am I adding? I'm adding 2. I'm adding 2 more. Those are my pieces to the puzzle. Okay? But then they say express the sum of the first and the third. What does sum mean? Sum means you add. So what we're going to do is take the first one and the third one and add them up. Now we never want to leave an expression like that. I want to simplify it if I can, and what I mean by that is combine like terms. I get 2x plus 4. And there we go. That's expressing the sum of the first and third as an algebraic expression. Okay, what we're going to do later on in this chapter is they're going to say the sum of the first and the third is 50. Okay, find the integers. Then we're going to have an equation that we need to solve. We'll get to that in a later section. Okay, so again, these last two things were just to kind of set the stage on some basic problems that we're going to see later on. But the bulk of this section is solving equations. Follow your 6 steps every single time and watch for mistakes step by step, not at the end. Checking at the end is great, but you should be checking as you go as well. As always, keep working hard. Let me know if you have any questions. I'll see you next time.